All right, here we go. So we are starting Unit 5 today. Oh my gosh, that's awesome. Unit 5, what's it about? Oh, I'll tell you. Thanks for asking. It is on quadratics, which is great because you've already seen these back in Algebra 1. This whole unit's going to be like a review, so I'm sure it's going to be really easy, right? Maybe. Sorry. So for today's lesson, we're going to just talk about a quadratic equation, how to write a quadratic equation. All right, that's all. And to do this, we're going to be able to write it from like looking at the graph of it, and we're going to be doing it from just if I get an equation, how can I rearrange it to make it in a better form, a special form. And here's the neat thing. Do you remember the beginning of the year, our very first unit on absolute value functions? That was like that V-shaped graph. And we talked about the equations that would like shift it, like move it to the left or right or up or down or flip it vertically or like stretches and compressions, things like that.
Yes, I remember that.
Okay, maybe if you don't, remember each little detail, do you at least remember vaguely like that concept? So these parabolas, these quadratic equations, they're going to follow those exact same rules. So like the first half of today's lesson is just going to be applying all those rules from absolute value functions to quadratic functions, and they're all exactly the same. All right. So if we look at the only difference here is that our parent function, instead of being an absolute value, so if you remember before with the absolute value, we had this equation f of x equals absolute value of x. Like that's what it was before. Now it's just going to be x squared instead. Okay? And that's what we're starting with. Over here, looking at this function, you got a bunch of different things that happen. All right, and we're going to be looking at this in more detail. So just real quick to give you an overview, to refresh your memory, a negative sign in front of the function. Do you remember what that does to the graph? It flips it, right? That'd be like a vertical flip. Yeah. And so that would be a V-flip. Same exact thing for a quadratic, okay? And I'm going to go over all these in more detail, but this is just like a little preview of what's to come. How about the number in front of like the absolute value? What would that do to our shape, to our graph? So that one is a bigger or smaller, like the stretch or compression. Okay, in this case, it's a 2, so that'd be a stretch and make it like more narrow. And then inside, we've got this -3. It's grouped with the x. What does that do to our graph? Carlos, yeah, do it again. Say, what's it do? Yes, exactly. Moves it to the right 3. And you said you didn't remember any of this. Good job. Moves it to the right 3. And how about the +1? What does that do to our graph? Do you remember? One more time. That would be like the coordinates of the vertex. And but just like a shift, like the -3 moved it right 3. What does the +1 do? Which way does it move it? It would move it up. So remember, for the vertical, it doesn't change the sign. That's just the one inside. So it's going to go up 1. All right, so you're already familiar with this. We're just going to apply it to the quadratic instead. But it should all be there somewhere in your minds from, like, what, 3 months ago? 4 months ago? 3. Just 3.
Mr. Wood.
Yeah, what's up?
Sorry I'm late. I got caught up in something.
Okay. Did you get out of something?
Yes.
Good. Wasn't like a bear trap. Those are hard to get out of, I heard.
Yeah.
Well, it was.
Yeah? Like you know what it's like to get out of a bear trap?
Yes.
We'll talk about that later. Moving on. All right, so writing quadratics in vertex form. This is our first target in Unit 5. Target 5.1. And so we're going to write a quadratic equation in a specific form. And this form is called vertex form. And most types of equations have different forms. Like with the line, we've got like slope-intercept form or point-slope form or standard form. Well, for a quadratic, we've got vertex form is what we're going to be learning first. And we like vertex form because it's pretty easy to graph. Now a quadratic is just a polynomial, so you can have multiple terms, with a degree of 2. Does anyone remember what degree means? The degree of a function is the what? Yeah, it's the exponent. Specifically, it's the biggest exponent. So the degree of 2 means the biggest exponent. So we could have something like 3x squared plus 5x minus 1. We could not have an x to the third power or an x to the fourth power. That would not be a quadratic. The biggest exponent on the variable would have to be a 2. And it has to have an x squared. If there's no x squared in it, it's not a quadratic either. And again, we're going to be looking at graphs today. And so the graph is a shape that you should all be familiar with. It's called a parabola, and it's basically like this U-shaped graph. It can open upwards or it can open downwards. It's still called a parabola either way. So that's what we'll be looking at for the first half of this lesson. I'm looking at the graph and then writing the equation of the parabola or the quadratic based on its graph. Yes. Oh, that's sad. Yeah, no more math study hall, 4th hour. Oh, well. Oh my gosh. Oh my gosh. It's been like 3 weeks. There hasn't been a math study hall. All right. Any questions yet? This is just the general overview. Okay, I know. Here's a lot. You don't need to write this down. This is all from our absolute value unit. You already have this in your notes from the first week of school, okay? I'm simply showing you how all 6 of these transformations that you have on the right, that was everything from the absolute value. That's from our earlier unit. All those exact same rules apply, but it's just instead of having, here's the only thing I really want you to write down is this absolute value of x. Instead of having that as like the grouping symbol for quadratics, it's going to be like a parentheses with a square outside of it. That's essentially like replacing the absolute value. Otherwise, every other rule is exactly the same as we had for the absolute value. Even, the vertical stretches and compressions at the bottom, where if that number in front of the absolute value of x was bigger than 1, like 2 or 3, it'd be a vertical stretch. It'd be like 3 times as tall. Or if that a is down here, if that's less than 1, like 0.5 or 2/3, then that would be a vertical compression. It's 2/3 like squished or half as tall if it's 0.5. Your flips are based off of the negative signs. If it's outside versus inside, outside it's vertical, inside with the x it's horizontal in the x direction. Horizontal shift, vertical shift, same thing. If it's grouped with the x, it's horizontal. If it's outside of the grouping, it's vertical. So like, for example, this would be parentheses x minus h parentheses squared, right? Just instead of those vertical absolute value bars, we're using parentheses with a square, an exponent outside of them. Everything else is the same as our first unit this year. You've all already learned this. It's back in your brain somewhere. It's going to be fun going back to this, right? Revisiting it. I'm sure some of you have missed this stuff.
I did, especially.
Yeah, the transformations of the absolute value function. So good. Oh, man. All right, I will go over this later, but I think we should jump into some examples now. Okay? And again, if you didn't get this written down, just leave some space and a whole minute. Whew. I'll put this back up in it like after the lesson if you want it. Or take a screenshot Ooh.
Or
Or a picture with your phone.
would it be for the random studies as well?
Yeah. You don't really have a question, do you? You're just trying to waste time. Mm-hmm. 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 I know, but I don't want other people just sitting here. Oh, okay. If he's good, then I'm assuming everyone is. Again, you've got this in your notebook already. Just look at the first page in your notebook. I'm sure it's there. Because everyone's that organized, right? Oh my gosh. All right, so these different transformations, we can put them all in a single equation and represent it in this equation in this form called vertex form. And in that orange box, so you don't need to write everything up top, just write vertex form, and then this is the equation. This is what it looks like. So you got your equation f of x, or y, equals a parentheses x minus h parentheses squared plus k. So this right here, this is our goal for today. We want to write the equation of a quadratic function in this form. We need to find out the value of a, the value of h, and the value of k. Those will be actual numbers in our equation, so that's our goal. If we determine those three numbers, then we've got the equation. And then down below, those are just reminders. A, the number in front of the function that's being multiplied, that's the stretch or compression factor. So if a is like a 5, that means it's going to be 5 times as tall, stretched vertically. If it's 1/4, something less than 1, then that's going to be 1/4 of the original size. That'll be like a compression. It'll be squished. H and K are the coordinates of the vertex, which is the same thing as the absolute value. So for the absolute value, the vertex was like the corner, like the nook in the V shape. For a parabola, the vertex is just like the bottom of the U, or if it's upside down, to be the top of the U. Same exact concept as your absolute value, okay? It's like I don't even need to teach this. You already know it already. As you're like scrambling to write everything down. You got this. That's true. That is true. You can't be underprepared. A few of us may have been underprepared. All right, so I'm going to have some graphs that are precise. Okay, don't worry about drawing them like with every single tally mark and crisscross. You don't have that much time, and that's okay. I just want you to follow along to get the main concept here. All right. First, remember I said there's 3 things you need to identify: A, H, and K. The first thing you want to identify from the graph is H and K, because all that is the coordinates of the vertex. So everybody, look at this parabola. What are the coordinates of the vertex? Yeah, you see that right here. Raise your hand if you think you can identify the coordinates of a vertex of a parabola. I'm hoping more of you can as well. And so that's your H and K. X is H, the Y coordinate is K. All right, so it's just an ordered pair, 0, 0. Remember, to write the equation, we need 3 things, A, H, and K. You've already got 2 of those. You already know H, and you already know K. Wasn't that easy? Yes, Mr. Wojcik. No, my lessons are always super easy and simple and basic to understand. Now, A is the last thing we need. This one we have to think a tiny bit about. Just a tiny bit. All right? So A is the vertical stretch or compression. Do you remember with absolute value? Let me just do a little demo over here. For absolute value, to determine if there was a stretch or compression, we had a pattern where like the slope was always like up 1 over 1, up 1 over 1, up 1 over 1. Do you remember that? And if it was like over 1 up 2, we knew that it was stretched like twice as tall, and you'd use a 2. We can kind of use a similar concept for the parabola, but it doesn't follow a 1, 1, over 1, up 1, over 1, up 1 pattern. Because this equation is x squared, And so whatever my x value is, like if I go to the right one, that's in the x direction 1 unit, my vertical move will be that distance squared. So from the vertex, if I go right 1 unit, well, 1 squared is 1, and I'm going up 1 unit because y is whatever the x distance is squared. Now, following that pattern, if I start at the vertex again and I go right 2 units, well, what's 2 squared? 4. So my y value would be that horizontal distance squared. So I'd go up 1, 2, 3, 4. Okay, what if I go right 3 units? How far up do I need to move? How'd you get 9? 3 squared, exactly. You go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So it's a little, this is the one difference of an absolute value from an absolute value graph. Okay, instead of going over 1, up 1, over 1, up 1, it's over 1, up 1, but then right 2, up 4, right 3, up 9. It's squaring that distance that you travel because of our function, because it is an x squared. Okay, the y is the x distance squared. So that's what we need to look out for. This right here, this pattern that you all just kind of discovered yourself, right 1, up 1, right 2, up 4, right 3, up 9, right? Because it's just squaring that x distance. So if you see this pattern occurring, and so you're going to have to actually map this out. You're going to have to look at the graph and determine, hey, if I go right 1, do I go up 1 unit? And if you do, that's great, because that means that a is equal to 1, meaning it's just like the parent function. There's no stretch or compression. It's going to match up with our basic parent function. So that's the pattern we want. 1, then the 4, then the 9. Okay, so I'm going to refer to this as the standard stretch, just because it's the basic parent function form, even though it means there's no stretch, but I just thought standard stretch sounds kind of cool. There's a little bit of alliteration there. Okay. This is in comm class. So that's what we're looking for. Now, how do we actually write the equation of the parabola? So I'm going to break it down into 4 basic steps for you. You should write down these 4 steps.
Okay. Thanks for that.
You're welcome. Step 1, identify the vertex. V-E-R.
Oh man,
Did you misspell it?
I put the X.
Whew.
I did.
T-E-X. I know, it's tricky.
There we go.
So identify the vertex. Look at this graph I've got up here. What are the coordinates of the vertex? 0, 2 or 2, 0?
0, 2.
Oh my gosh. Hey, alphabetically, which letter comes first, X or Y?
X.
X. Is X the horizontal or the vertical?
Vertical. Letter horizontal. Jesus.
Is it 2, 0 or 0, 2?
0, 2.
2, 0.
0.
This is the X-axis.
Man,
This is the Y-axis.
I don't want to talk about it.
1, 2.
I don't care.
X coordinate of 2, Y coordinate of 0. So the vertex is at 2, 0.
Man, I must have done some finish wrong now.
Oof. So that's step 1. I think we're all pretty good at step 1, aren't we? Well,
No.
oh my gosh.
Let's go over again.
Step 2. Okay, this is the only thinking part, everybody. Step 2 is the only part you have to actually use your brain. Well, X before Y. All right, check for a stretch or compression. That's going to be A. So here's where we want to use that, check for that standard stretch or not. Start at the vertex. And if I move right 1, do I move up 1? Well, in this case, instead of up, we're moving down. So if I move right 1, do I move down 1? Right 1. Down 1, I'm on the graph. Or from the vertex, if I move right 2, I move down 1, 2, 3, 4, and I'm on the graph. Is that our standard stretch pattern right there? Over 1, up 1 or down 1 over 2 vertically 4. Yeah, isn't that vertical distance just the square of the horizontal? Yeah, that's good. That tells us that A equals 1, meaning there's no stretch or compression, okay? So basically there's no coefficient. There's not going to be a number in front of the parenthesis. Step 3, though, is it's flipped. Is this parabola open upwards or downwards?
Downwards.
And is downwards positive or negative?
Negative.
It's negative. So yes, it's flipped, meaning we're just going to have a negative sign in front of it.
When you go like this.
So now we just put that information together to write the equation. F of x equals, so first it's been flipped, so I start with a negative. Next, I put A, my stretch or compression. However, in this case, A is a 1. I don't need to write that because multiplying by 1 won't change the value. You can if you want to. It's not wrong, but it's unnecessary. Parentheses, x minus h. This is h, that's k. So x minus 2. Remember, only the x is the opposite sign. X is the only one that's backwards. I would then, if I had a k, like it would go here, like plus 0, outside of the parentheses. Oh, and we need to square it, right? That's the one thing that makes us a quadratic, is that exponent of a 2.
Is it always going to be x minus something?
If, only time it wouldn't is if h were like a negative 3. It's the opposite sign. So in this case, it would be like parentheses x plus 3 squared, right? You flip the sign of the x coordinate, which is exactly what we did with the absolute value, if you remember that from way back when. And that is the equation in vertex form. Well, I don't need to write the plus 0. So negative parentheses x minus 2 squared. Think you could do that on a test? If we practice a little, which we will. I got a few of these to go through. And we do have a test in 2 weeks. It's going to be awesome.
Is that the final week before Christmas?
Yes. It'll be like your last day. It'll be your last class of 2020 in all. It's so exciting. But unless you're in first or second hour, then you're going to be, I don't know when. Oh, after break then. The virtual Monday and Tuesday after New Year's.
Oh my God. That's
No. The test, everyone's taking the test that week. Oh my gosh.
Our exam schedule is something better than the
It's so weird.
We get the whole week off.
Okay. So everyone, example 1, write this equation in vertex form. And you're going to talk me through this. Okay, we're going to follow along with the steps. So step 1, identify the vertex. Who can tell me the vertex of this parabola? Anyone agree with Shyla? -3, -2? -3, -2. Good. Step 2 is to look for A, that stretch or compression.
Do the thing.
Do the thingy.
It's not.
Is there a stretch or compression?
No.
How do you know?
Because I was drawing the little lines in my head.
Yeah, following that pattern. Right 1, up 1, we're good. Right 2, up 4, we're good. That's the standard pattern, right? So there is no stretch or compression. A equals 1. Nothing we need to do then. We're not even going to put that into our final equation. Step 3, is this parabola flipped?
It's flipped up.
Well, that's the standard position, right? That's the parent function position, is opening upwards in the positive direction. So we don't need to write anything. It's not flipped,
Well, this is an easy problem.
right?
Thought you were going to give us a challenge.
So now write it. Yep, everyone, I'd like you to try to write this equation down right now. Take 20 seconds. All right, so no negative sign, and a is 1, so I'm just going to go right to the parenthesis, right? There's nothing in front of the parentheses then. X plus 3 or minus 3? Plus, you flip the sign only for the x. Plus 3, and remember the exponent. Did you remember the squared?
Yeah.
And then what's going to come after this?
Subtract 2.
Minus 2. Exactly, because the y coordinate of the vertex is down 2 units, so it's a negative 2. That's not too bad, right? Piece of cake. Man, this is easy when a equals 1. Guess what's next? For different values of a, you need to look for the change in that over and up pattern, or over and down if it's been flipped. And so, obviously, this one's a bit different. So let's figure it out. Start at the vertex, and if I go right 1, 1, 2, 3. And what about, if I go right 2, 1, 2, 3, 4, 5, 6, 7, 8,
Oh, I was close.
9, 10, 11,
12.
12. Wow, right 2 up 12. Huh. All right, so on the left, this is over that same problem. On the left, that's our standard pattern, right? Right 1, up 1, right 2, up 4, where it's just squared for that vertical distance. On the right side, the new function, when we went right 1, we went up 3. If I went right 2 units, we went up 12. So how many times bigger are these numbers from what they're supposed to be in our basic parent function? How many times bigger?
Pick me.
Keegan,
It's cubed.
just say the number.
3.
3 times bigger. All right, so it's exactly 3 times bigger. And so A is 3. That's all you do. You compare it to the standard like vertical distance, and hey, each of those numbers was 3 times bigger than the normal one. Therefore, A is 3. It's as easy as that. Oh, so that's your coefficient in front of the function. All the other rules are the same. If the parabola were shifted up, down, left, right, you'd have the h and the k. The only difference is that there'd be a 3 out in front of the parentheses. We didn't have room on the graph, but on this new function, if we went right 3 units, how far up would we have to move? Excellent. How'd you get that, Avery? Multiply by 3? Yeah. Instead of going up 9, you're going up 3 times 9, which is 27. Exactly.
107.
What? All right. So here's another one for us, and spoiler alert, A is not going to be 1 for this problem. Okay, first off, what's the vertex, everybody? You got this.
1, 0.
Look who knows his alphabet. Not bad. 1, 0. All right, now, though, what's the value of A for this parabola?
2.
It's 2.
Nope, it's not 2.
Oh, it's undefined.
It's 1.
It's not 1.
It's undefined.
It's not undefined.
Oh,
It's 2.
It's red eye.
is this kind of
You really got us.
From the vertex, normally if I go right 1, I should go up how far? Okay, which I don't. It's right here. And that's not quite 1 yet, is it? Is that bigger than 1 or less than 1? It's less. So we're going to have a fraction in front, okay? Now, instead of just guessing like, oh, that's about 7/10. It looks like it, but let's be sure.
no.
Oh my gosh. Next time, like, if you ever have to go to like the doctor's office for anything and they're like, hey, let's give you 200 milligrams of this medicine. Just give me like twice-ish. I don't really care. Doesn't really matter if we're off by that. If I go right 2, look at this. How far up did we go? Exactly 2. Do you remember what the normal vertical position is for moving 2 to the right? It's normally 4, right? 2 squared. Instead of up 4, we're going up 2. It is 1/2, right? Hey, check that out. Okay, if I go right 1, 2, 3, went up 1, 2, 3, 4, and about a half, which is half of which number? 9. Oh my gosh, yes. Yes. Great job, everybody. So in this case, A is 1/2. Now, to be certain, check all 3 of those, and one of them should be like right on a line, like an axis, where you can get the exact number instead of guessing, oh, it's half-ish. No, because 5 squared is 25. That's not an even number.
Here we go.
10 would be on a line. Be right on 50. But if you go right 5, the vertical distance would be 5 squared, which is 25. You'd go half of 25, which is 12.5, as Landon said. Hey, is this graph flipped? No. Okay, write the equation, everybody. Using H, K, and A. Ten more seconds. 10 more seconds.
And the price is right.
What does that have to do? Okay. F of x equals, do I put a negative sign here?
No.
No, because it's not flipped. How about A? Do I need to write A?
Yes.
Yes, what is A?
1/2.
1/2. Parentheses. X minus 1. Squared.
That's it.
Right. We don't do anything else. Plus 0. If you add 0 to something, it doesn't change it, so don't even write the plus 0. That's it. 1/2 x minus 1 squared. Cool? Honestly, how are we feeling so far?
CC.
It's okay, right? And that's the trickiest part, figuring out A. It's not that bad.
Get worse.
All right, so I just have 3 more practice ones for us to do together. All right? What?
I thought it didn't touch it the right way. I was like, oh god, it's gonna get.
Okay, what do we do first?
Find a
Vertex. Carlos says 1, 4. Anyone agree? You're a brave man. Number 2. What's A?
Oh, that's a hard one.
It goes right 1 down 2. So this will be 2.
Why do you think it's 2?
That doesn't.
Wait, what?
Is it 4?
1,
Undefined.
Normally, when you move right 1, we should move down how far?
3.
Remember, square 1, right? Normally, it's normally right 1, down 1. It's not. It's right 1, down 2. So how many times bigger is it than what it's supposed to be? 2. Does it work anywhere else? Normally, if I go right 2, we should go 1, 2, 3, 4, 5, 6, 7, 8. Is that twice as big as 4? It is. So A is exactly 2.
Wait, if it's going down, doesn't matter if it's a negative, whatever negative or not?
So that's what step 3 is, remember? The flip.
Oh, wait, so it's flipped, so it is negative.
It will be so what will like be in front of the parentheses for this equation? A negative and the 2. Right. So step 3 is our parabola flipped?
Yes.
It is flipped.
Oh, yeah.
Yes. So that means we're going to have a negative in front of it. And now we just put put these three pieces of information together. F of x equals -2, parentheses, good, don't forget the squared, and then the +4. Yeah. Isn't that crazy? Like, you just wrote the equation of that graph over there just from your brains like that. That's pretty impressive.
River didn't do it.
Whoa, whoa, whoa. No, he's working hard, right, River? You're doing your assignment. You're following along, aren't you?
Of course I am.
Ooh. All right. Try this one. Yep, go ahead and just write out those 4 steps for me. I'm going to give you 40 seconds to do the whole thing. 10 seconds per step.
Oh my god, you're just so nice to us today.
Yeah, it was.
Oh, here we go, man.
Okay, I was having trouble finding it.
Okay, I'm done.
I did it too.
Got 10 seconds left. You finished early. What?
Well, I realized that you were really nice to us on this problem.
Why was I nice to you?
Because it's the pattern.
Because A equals 1. Yep.
There's no flip.
And there's no flip. Yep. So the only thing we need to worry about is H and K. What are the coordinates of the vertex? -1, comma 4. 2. What's A? Right 1, up 1. Right 2, up 4. Follows that standard pattern. So A is 1. We don't need to worry about it. 3. Is this flipped? Nope. Don't need to worry about it. 4. F of x equals. Yeah, we go to the parentheses right away.
X plus 1
Squared plus 4.
plus 4.
Oh my gosh.
Let's go, Carlos. We just teamwork that one.
Are we gonna have delta math?
Yep.
This
Just doing this. Isn't that awesome? Actually, it's multiple choice on Delta Math. I give you a graph, and you have 4 options of equations,
Oh, I'm gonna speed run that.
right?
Yeah, we can just get
And now I think on Delta Math, I don't believe any of them have A being a value other than 1.
Oh, let's go.
Sorry about that, but I will be testing you on that.
Don't be sorry.
I know.
Maybe you should write email to Delta Math.
You know what? I will.
There you go.
I'll email Zach right after class today.
Are you personal friend with him?
I've emailed him once or twice.
Yeah.
Caught some bugs in his code. Yeah.
Like personally or?
Yeah.
What do you say?
He goes, "Oh yeah, thanks for that." One of his sites wasn't loading up, or one of the problems. I said, "Hey, none of these exercises work. What's going on?" He goes, "Oh yeah, we just updated a new firmware bug to that or whatever, and it's fixed now. Thanks for the heads up." I'm like, "You're welcome."
Ooh.
I know.
So,
He's a cool guy.
It's gonna be on the payroll.
I mean,
I know.
he was a full-time math teacher who made Delta Math in his free time because he's good at programming. And so I respect that as well, because I teach computer science as well. So I'm like, that's phenomenal to code all that, which he did all that by himself. One guy. No, I cannot do that.
Why not? You're the computer scientist.
Thanks, everybody.
Follow your
We need the Wojcik math.
I'll believe in myself as a teacher once I figure out a way to get kids to actually do their homework on their own the night that they're assigned.
Oh,
Wait, what do you like? You did it the night of?
No.
I did homework that was due from like September.
I'm still on Kramer's rules.
Kramer's rule.
I got 1 done today.
Yeah. It's like, Wojcik, can you update my geometry grade? I fully understand circles. Hey, write the equation of this parabola in vertex form, please.
Uh-oh. No, we're good.
Yeah, you're good.
Uh-oh.
Sheesh. I got it.
Wait, don't rush me. Wait. Oh, wait. I know what to do.
got it?
I think so. If I didn't, it'll be a
Let's go.
embarrassed.
Darn, it's really exciting.
Yeah, this is kind of fun, isn't it?
Oh yeah.
A little bit.
We need to start challenging for teaching, so you're gonna have to start solving those Rubik's cubes while you're doing the math problems for us.
You're all doing so well. You're going to be solving these before I can even solve a Rubik's Cube.
Yeah, well, I mean,
Don't worry, there's still the second part of today's lesson.
Wait, what?
Mwahaha.
is it the quadratic formula?
No, we're going to do that on Wednesday next week.
Wednesday? You think we're gonna get it down in 30 minutes?
Yeah, you've already learned it in Algebra 1.
Oh gosh, no.
That was so long.
That's like a memory.
It's-
fast.
Bless you. It's not that I don't believe in your ability to learn, but I believe that much in my ability to teach.
Oh, I thought you could say I
Dang, go on.
Right? Like, I'm pretty sure you can all do this.
Mr. Johnson.
I'll show it nice and easy. Hey, Vertex, where we at?
We're at 0, -1.
Ooh, someone learned his alphabet. What's A?
1.
A is just 1. Nice and easy.
Then it
Go
is-
over 1.
and guess
and
what?
down
It's
1.
flipped.
Is it?
It is.
It's flipped, so we've got a negative sign is going to be in front of our parenthesis. And finally, f of x. That's not f of x.
You wrote too many F's.
It's kind of like someone's report card. Not any of yours. Not any of yours. You're all bright students. The only thing I could spell with your report cards, I'm sure, is ah, right? Because all those A's you got.
More like
Negative, I agree. Yep, yep,
Nope.
yep,
Oh,
Yes.
yeah.
Yes.
I
yep.
did the minus there.
Let's go, Landon. You got it right.
All right, pop quiz question though. Is this the same as this?
No, it's not.
Nope. Nope. Yep.
No, it isn't.
Yep.
No, it's not.
Nope. No, because the multiply. Oh no. Wait.
Because
So
if
the
you
X times
square
X
that,
is
then it's not.
No, because the negative. the
Which operation do we do first?
Time dash.
Okay, what's P stand for?
Parentheses.
What's the E stand for?
Exponents.
So in both of these scenarios, I'm going to do the parentheses first. Well, there's nothing to do inside of those parentheses, right?
Yeah.
Now, look right here. Do I take care of the negative first or the exponent first? Exponents comes next, right? So I'd still square x first, and then technically I'm multiplying by a -1. That's what a negative sign out in front really means. It means you're multiplying by a -1. So these both are the same. I don't know. All right, so you don't need those parentheses. Hey, but remember, if we're adding or subtracting from the x, then we would, right? If it were like x plus 3 squared, obviously that's very different from x plus 3 squared. You can all see that difference, right? Like that's crazy different. That'd be like a -x plus 9. Okay. So that's it for writing quadratics from a graph.
Next lesson. Can you teach it in 48 minutes?
Oh, we got time. All right, first off, I want to make sure you're ready. That didn't like blow your brain out of the water or anything, did it? It's not mush yet.
Let's get it going.
Yeah, let's get it going.
Let's run the ladder.
It's something new. It's a new skill. We'll just put it like that. But hey, this is Algebra 2. We're all about learning new skills, right? We're teaching our brain to think differently, solve different types of problems. Whew.
Oh, I remember standard form.
Yeah. Okay, so the second part of today's lesson, it's still writing the equation in Vertex form. However, it's not from a graph. This is going to be if we're given the equation in a different form and we want to rewrite it in Vertex form. It's like if you're ever graphing a line, do you ever rewrite the equation to go to like slope-intercept form? Don't you do that to make it easier to graph sometimes? Same idea here. If you have a parabola that you want to graph and it's given in standard form, chances are you want to rewrite it to get it in this vertex form because it'll be a lot easier to graph that way. So to get it into vertex form, I mean, you don't need to write all of this stuff up here. Basically just the table on the bottom. And then this process is what we're going to be learning today. A process called completing the square. And that's what we're going to be learning. It's a new skill. And we have to use this technique to write the equation from standard form into vertex form. We get to do this thing called completing the square. And completing the square, it's going to be a little weird at first, but we're going to be using it not only to rewrite in vertex form, but we're going to be using completing the square to solve quadratics later this year. And completing the square is going to be very important in every single math class you take after Algebra 2. It becomes a very important skill. And so this is going to be just your first little snapshot into it. If you don't have it completely mastered after today, that's fine. We're going to keep coming back to it. Standard form of a quadratic equation is probably what you saw back in Algebra 1. This right here, ax squared plus bx plus c. And so far today, we kind of talked about that quadratic formula a little bit. And the three variables in the quadratic formula are a, b, and c. And they come from the standard form. So if you're using the quadratic formula, you do want it in standard form, right? But if we're graphing it, we're probably going to want it in vertex form over here. It's going to be a little bit easier to graph because you've got that like h and k as your vertex right away. You don't even need to really think about it. You can just plot that. And whatever a is, you can just make your, over 1, up 1, over 2, up 4 pattern. Unless a is something different, then you just multiply it by that amount. Then that last row, I just give two examples of what these would actually look like. So x squared plus 8x plus 16, that's a quadratic written in standard form. On the right, x plus 4 squared, that's actually the exact same equation, just written in vertex form. Those are two equations for the exact same parabola. What? Is that nuts? So that's what we're going to learn, how to go from this form to that form. Yeah, we're totally going to do it. It's going to be epic. Should we get started? Yeah. Love this enthusiasm. Let's rock and roll. Don't write this all down. We're going to play a little game. I've got a bunch of different equations on the left written in standard form. And I've got those same parabolas, those same quadratics, written in vertex form on the right. So every one of these are equal. What I want you to do is see if you can find the pattern, a connection between the standard form and the vertex form of each of these quadratics. And then try to generalize it down here, like based on that general form with B, C, and H. So these are our numbers, the B, the C, and the H. We want to find that connection.
I got it. Easy.
Yeah?
Yep.
You see a pattern?
Yep.
Avery, what do you think?
The third number is square, the second number is times 2, and the first one is always square.
Yeah. So like this number on the right, that H, for example, the 12. If you take 12 and you square it, you get 144. If you take 12 and you double it, you get 24, right? Is that what you're saying? That's right. So there's this relationship here. If I have an equation in this form, I know that this number right here, B, if I divide that by 2 and then square it, I get this number, the 144. Right? Does that work for every one of these? What's half of 6? 3. And what's 3 squared? 9. What about 10? What's half of 10? Half of negative 10, sure. It's negative 5. And what's negative 5 squared? Positive 25. And notice whatever we get when we cut it in half, that's actually this number over here. Right? And yeah, good observation. That's right. If this is positive, the vertex form will be positive. If this is a negative, B is negative, then it's going to be negative in the vertex form. Excellent observation. That's great. So that's the pattern. That's the relationship that we're going to use to convert from standard form on the left to vertex form on the right.
This is gonna get messy when we get to fractions.
Yeah, that's the last slide. The last two slides are fractions. All right, so the h from vertex form, basically that was that last number you saw in the parentheses. Remember h and k? It's half of b and the square root of c. All right, so this just looks like hieroglyphics, I'm guessing. Here's what I want you to write down. Just that. This right here is what I call the magic number. Did you say Jonathan? Parentheses. So C, remember in standard form, C is the constant. That's that third number in the form ax squared plus bx plus c. And if C, that constant, is equal to half of b squared. Remember how I kind of showed that? Like 10 divided by 2 is 5, or negative 5, and then squared is 25. If it meets up that pattern, then we have what's called a perfect square trinomial. I want you to write that phrase down, a perfect square trinomial, because that's our goal. If a quadratic is a perfect square trinomial, then that means that it meets this special pattern where C, the constant, is half of b squared. And then that means that we can easily write this in vertex form just by taking half of b. So that's our goal. I know these are just baby steps. So we want to get this standard form needs to be a perfect square trinomial in order for us to convert it to that vertex form. And a perfect square trinomial means that b and c have this relationship that I've got in the box, where c is that magical number. That's exactly half of b squared. Okay so far? We're going to look at some, I've got some examples where I'm just going to have you tell me, hey, is this a perfect square trinomial, yes or no, okay? See if it's got this pattern. All right, so I know it says rewrite in vertex form, just look at these three. This first one, is this a perfect square trinomial? So to determine that, look at b, divide it by 2, and square it. What's half of 100? 50. And what's 50 squared? It's exactly this. All right, so is that a perfect square trinomial? Yes. How about the second one? Take half of negative 16 and then square it. That works, doesn't it? How about the third one? Is that a perfect square trinomial? How do you know?
2 plus 2 is 4, 2 times 2 is 4.
Yeah, half of 4 is 2. 2 squared is 4. Okay, so all three of these are perfect square trinomials. Since they are perfect square trinomials, we can easily write it in vertex form simply by writing it as x plus half of b, right? Whatever that middle step was, which in this case is 50. So I want you to write those next two in vertex form as well. It's very easy. I'll give you 10 more seconds. Because we've already confirmed that these are all perfect square trinomials. So we should be able to write them very quickly and easily in vertex form. All right, what's the second one? X minus 8. So this is a little different, remember, because there's a minus sign in front of b, so that negative comes with it. And how about this last one? Guess what, everybody? You all just rewrote those standard form quadratics in vertex form. That was pretty easy, right?
Yeah, but those are
What do you mean? Am I going to make it more difficult than this, you think?
Not if you stall.
Oh, yeah, because that'll work. You stall and I just don't teach it, or do we just take longer and have to get through more material the next day? Saturday. All right, so obviously it's not always going to be that easy. It'll probably never be that easy. Okay, typically C is not going to equal that magic number that we want. It's not always going to be half of B squared. So instead we got to do a little bit of algebra. But what's cool is we can just make an equation a perfect square trinomial if we wanted. So let's say I've got this quadratic in standard form, x squared minus 14x plus some number. What number would we want C to actually be for it to make that special pattern? What is the magic number that we want for this equation? How'd you get 49? Okay, did everyone follow along? She said take half of 14, which is 7, then square that number. And well, negative 7 times negative 7 is a positive 49. So if C were a 49, we'd get x squared minus 14x plus 49. That's a perfect square trinomial now, isn't it? Can we write this in vertex form really easily? What is it? X minus 7 squared. Right. That's nice, isn't it? So that's how you can recognize that. It's going to be pretty much that same thing, though, with one extra little step. But first, I want you all to figure out what are the magic numbers for all three of these. What would C have to be to make each of these a perfect square trinomial? Don't shout it out loud, please. Don't steal the magic from everyone else. You're excited, though, aren't you? You're like, you get it, don't you?
Oh, yeah, I just did like 2 seconds.
Good. 2 seconds.
No. It was 9 seconds.
2 seconds. It's about how fast you did your delta math. I think it was solving radical equations.
Oh yeah, because
Where like you had to, when I had two different terms on one side. Remember my really long example I did at the end of class on Tuesday when you had to like FOIL twice?
Oh, yeah.
Yeah, he's doing those in 11 seconds. I'm like,
29 seconds.
Okay.
You showed me. You sent me a screenshot.
Wait, it tells you how long it takes?
Yes, it does. All right, everyone, what's the magic number for this first one?
It is 36.
Yeah, you take half of 12 and you square it, you get 36. How about for the second one? What's our magic number?
4. Positive 4.
4. And how about the last one?
81.
Anyone else get those three numbers? Those three magic numbers? Yes. So we've made each one a perfect square trinomial. So what would each of these be in vertex form? Just do that real quick.
X plus 6 squared.
X plus 6 squared. What's the next one?
X minus 2 squared.
Ooh, he's on a roll. How about the last one?
X plus 9 squared.
I can't.
X plus blah. Right. Look at that. We just wrote each of these in from standard form to vertex form. But what's the catch here?
It's too easy.
We don't actually get to pick that number, do we? If I have an equation, there's going to be a number there already. So what do we do? Like this right here. Is that a perfect square trinomial?
Yes. No. I'm throwing you for a loop.
Don't.
You're throwing a curveball.
So check it out. If this constant doesn't meet our pattern that we like, what if we just got rid of it? That's a positive 7. How can I get rid of a positive 7?
Subtract 7.
So check this out. What we're going to do, just temporarily, Okay, we're going to subtract a 7, but don't I have to do that on both sides to keep it balanced? Essentially, what if I just temporarily move it over to the left? So that now our equation is y minus 7 equals x squared plus 10x. Well, that just canceled that out. Those equations are the same, aren't they? Now, we want this to be a perfect square trinomial. So here's where we get to have that fun that we wanted. What is the magic number that we want to have as a constant? What's half of 10? And then squared. Don't we want this to be a 25?
I thought I was wrong for a second.
No, you're good. It's just people were distracted because someone walked by the window.
No, he was pointing at me.
Weird. Everyone agree with that? We want this to be a 25, don't we? To make it a perfect square trinomial. But am I allowed to just magically add a number to one side of an equation? What else would I have to do? Yeah. Can I add it to the other side too? Sure. Let's add it over here.
Wait. This is crazy now.
It's going to be one more step, and you're going to be like, what? It's going to be so great.
I believe in you.
Add, right? Am I allowed to add 25 to both sides of an equation to keep it balanced? Do you understand why we added 25 to the right side? We wanted to make this a perfect square trinomial, right? I wanted 25 to be that magic number, okay? Now, on the left side, we already had a negative 7, and I added 25. What will this become now? Y plus 18, right? I just added the negative 7 and the 25, right? We'd have to add, they're combining like terms. But watch this. How can I rewrite this right side now in vertex form?
Oh,
Remember the
You put the plus.
minus 5 plus 5 plus 5 squared.
Whoa.
And then you put the plus 18 at the very end, Dave.
Not plus 18.
No, I'm sorry. It's subtracting 17.
Do you see that? Do you see how easy that is?
Wait, subtract what?
So look, this is vertex form now, right?
Right.
But ultimately, we want our equation to just be y equals by itself. So how do I get rid of that 18? Just subtract it. Oh my gosh, I see eyes like lighting up right now with understanding, and that is the coolest thing you can imagine. So how about this?
If you got it.
Y equals x plus 5 squared minus 18. Hey, is this vertex form, everybody?
Yes, sir.
Didn't that actually end up kind of nice?
That was kind of fun.
It's kind of slick.
Now was that easy one? Or was that a hard
That's a normal one.
one? Oh, I like it.
So we're calling that average.
Average, we'll say. That's a middle one. No fractions, right?
No fraction.
Now, here's the cool thing. I want you to tell me what the coordinates of this vertex are.
Oh, negative 5.
Negative 5, negative 18. Look how quick that was.
Oh, yeah.
We could graph this. Hey, what's A?
It is 1.
Does this open upwards or downwards?
Upwards.
Couldn't you graph this pretty easily now?
Yeah.
Like that. You put the vertex at negative 5, negative 18. You go over 1, up 1, over 2, up 4. Follows that standard pattern. Maybe like that. Like 5 snaps.
So I can take the test now.
You're ready, aren't you?
Yeah.
This isn't that bad, right?
No.
It falls into place nicely. Okay, but obviously we've got to practice this. There were still quite a few steps. Well, no, we're just going to practice. Okay, so everyone write this down. Y equals x squared minus 12x plus 4. I'll talk you through it again. If you feel confident enough and want to do it on your own without listening to me, you can. Is this a perfect square trinomial right now? No, it's not. That 4 doesn't fit our pattern, so we need to get rid of it. So I'm going to just temporarily move it over to the other side because I don't want that number there. That doesn't fit my pattern. So we have y minus 4 equals x squared minus 12x. What is the magic number that we want for this problem? 36. You take half of 12, half of negative 12, and you square it. I want this to be a plus 36. So I go ahead and I add that on both sides.
So you go like this and go what?
On the left side, 36 minus 4 gives me 32.
Wait, don't you subtract it?
Not yet.
So to keep, since this is your equal sign, think of it like a teeter-totter. If I add 36 to one side, I have to add 36 to the other side.
Then you go like this, and I'm done.
Then equals parentheses x plus 6.
Oh, so close.
And
See the sign of the middle term? Since this 12 is negative, Carlos, it's got to be negative here also, okay?
I thought we had a flip sign.
Nope. That's if we're graphing it, we would, right? The vertex would be at positive 6. Yep, last step, just get rid of the 32.
And you subtract it over.
Y equals x minus 6 squared minus 32. Anybody have this? Whoa! Yes! Oh, that's awesome. I am so proud of you.
Now for the hard one.
It's not that bad, right? No, we'll do another one like this.
Like this.
First, any other questions on any of these steps at this point? I don't want to fly too fast, but we're doing great.
Oh, free. It's free.
All right, example 8.
Oh, I got this one over your block.
Y equals x squared plus 18x minus 1.
Plus one, get that one out of here.
So that 1 doesn't fit our pattern, right? That's not the magic number that we want there. So we got to get rid of it by adding 1 to both sides. Now, I want to add the magic number. What is it in this case? So you take half of b and square it. Half of 18 is 9. 9 squared is 81. So 81 is the magic number that I want there. That makes this a perfect square trinomial. But then I'd have to also add 81 to the other side to keep this equation balanced.
Doozy.
82 equals x. Here I just take half of b. Half of positive 18. It's positive 9 squared. Isn't that a pretty easy step? Just taking it in half right away?
Don't forget to subtract your 82, sir.
Oh, someone's getting excited. Someone might actually do his delta math himself tonight. I'm just kidding. Tuesday morning.
You're not wrong.
Y equals x plus 9 squared minus 82. Anyone have that? Oh, that's terrific. Oh my gosh, perfect. Every single student here got it. That is so exciting. Well done.
Go to the hard one now. Give it to us way
You
out.
sure? Are you ready for the more challenging ones? I feel like I should encourage this. Right now, we're in a good place, aren't we?
Way out
Let's
thick.
just cut it here.
I know. Yeah, maybe we should just stop.
Yeah.
When the corn gets tough, you push through the wall.
Oh my goodness. Well, here's the wall.
Wait a minute. It's 4x.
Here's the difference, everybody. All of those ones we did, x squared didn't have a coefficient. Well, it was a 1, right?
Wait, is that going to be the A?
No. Well, no. Yes.
Can't you just simplify
But we have to
5 by 4?
Yes. Well, I mean, I do say that here. Just divide every term by a. So,
You just said the lane, that's not it.
no. Well, there's two different a's. There's a in vertex form and there's a in standard form, which they are the same, but yes. But just wait. Yeah, it'd be the same thing in both forms. Well, I just don't want you to. Oh my gosh. Oh my gosh. I just volunteer here. Yes, I am a permanent Port Pride volunteer.
Wait.
What exam do you
I get to exempt every exam of my life because I've got like 2 million. Anyways. All right, so here's what you want to do, everybody. If you see an equation in standard form and the x squared has a coefficient in front of it, other than that invisible 1, right? That's what we love. I don't want anything in front of it because that little trick we use to find that magic number doesn't work when there's something in front of the x squared. I don't want this 4 there, so I'm going to get rid of it by dividing by 4. But here's where you got to be careful. I can't just divide one term by 4. I have to divide every term by 4 and the y. And the y has to be divided by 4. Just temporarily. Remember how before we would like subtract a number and then bring it back in the end? Same idea here. We're going to divide by 4 just for now. We're going to multiply it back on at the end. You got it, man. So this is now y over 4 equals x squared minus 10x
That clearly doesn't work.
minus 6.
So, you gotta add that 6 over.
Okay. Yeah, this negative 6 is not our magic number that we want. It doesn't make this a perfect square trinomial, so we've got to get rid of that also. So I'm going to move the 6 over to the left side as well.
Now it's like a party.
Oh, man. They're having so much fun. So I need to add 6. Add 6. Do I add the 6 to the 4 that's on the left? Or did I just write it separately?
You start it separately.
Good. Yeah, because I've got y over 4 plus 6. The left side should look kind of like this. All right, y over 4 plus 6 equals x squared minus 10x.
Plus 25.
Where'd the 25 come from?
The magic number.
and half is 5. 5
Uh-huh.
squared is 25.
That's right. That's the magic number. Half of 10 is 5. 5 squared is 25.
Take that, then.
But hey, if I add 25 on the right side,
Yeah, it's the left side.
add it to the left. Plus 25.
And now you're gonna have to teach us how to do this.
All right, so let's clean this up a little bit. Y over 4 plus how much?
31.
31. I just added the 6 and the 25 together. They're both like terms. Equals, hey, what's the right side look like now? Remember, we're going to put that in vertex form. What's that going to be?
X minus 5.
Squared.
Good. At this point, we're just trying to get the y by itself now. What do I get rid of first, the 31 or the 4? The 31. Yep.
Oh, so what, the 4 become where your A is supposed to be at that?
Not just there, though.
Oh, it also multiplied to your 31 too.
There you go.
Okay.
Now I have to multiply.
So on the right side, so we subtracted 31. I still have a 4 over there, a divided by 4. I need to get the y by itself. And so the opposite of dividing by 4, isn't that just multiplying by 4? And that'll cancel out. But here's where you have to be careful. I actually have 2 different terms on the right side, so they both need to be multiplied by 4. But it's not that bad. When I multiply this first parenthesis by 4, because this is like locked into these parentheses being squared, I don't actually distribute or move that 4 inside of it. All you do, put the 4 right in front. Okay, there's actually not even a calculation here. You just put that 4 in front of that parenthesis. But I do have to multiply the constant by 4 as well, which
124.
y equals 4 parentheses x minus 5 squared minus how much?
Negative 124.
Anyone else get that?
I did.
That's nice.
Now about the figures.
And that is it. That is now written in vertex form. What are the coordinates of the vertex of this parabola? Good. Positive 5, negative 124. Awesome. Does this parabola open upwards or downwards?
Upwards.
Upwards. And has it been stretched or compressed?
Stretch.
By how much? Yes. Oh my gosh. I should test you on absolute value functions again, right?
No.
I'd be fine with it.
I mean, after doing this, you should probably do better on it, right? That could bump up that target's grade.
You can have a C on that.
What one do you not see?
All right, what do you think? Can you handle this? Okay, let's practice another one.
Oh.
It's going to be this similar thing.
Don't say the answer until I get it done.
Okay. Y equals negative 3x squared plus 18x minus 6. Before we try to complete the square or anything, what do we have to do? Divide by negative 3. Good, because there's a coefficient in front of the x squared that's not a positive 1, or that invisible 1 that we love. We want to temporarily get rid of it by dividing every term, including the y, by a negative 3. Careful when you divide by a negative, by the way.
Got it.
Already?
Yeah.
All right, so I divided everything by a negative 3, and then I subtracted 2, and now I need to add my magic number. What magic number are we using for this one? Positive 9.
Yeah. This one.
'Cause it's negative 3,
Oh, you're trying to-
and then squared.
That's why.
Yep. So plus 9, plus 9. So y over negative 3 plus 7, because I'm going to combine it with that negative 2, equals, what's the vertex form going to be on the right? Perfect. X minus 3 squared.
This will be an easy test.
Subtract the 7, multiply by negative 3. I'll do it one step at a time still, though.
Yeah, that's what I did.
Equals x minus 3 squared, and I'm subtracting a 7 because it was a plus 7. Then last thing, multiply by a negative 3. Now remember, for this first one, you just put that negative 3 in front of the parentheses. Do not distribute it in or anything like that. Then I also have to multiply the negative 3 times the negative 7. Anyone get plus 21?
I did.
Oh, all right, all right. And we've got this equation now written in vertex form. So this would be super easy to graph.
Okay.
Tons of time left.
Killed it.
But wait,
We got some more practice.
but wait.
There's more.
Remember what I said the last type of problem I'm going to show you involves?
No, I don't think so.
I don't like that.
Yeah, I'm gonna go with that.
Ooh, fractions. Sometimes that coefficient is a fraction.
Oh, wow, that was super cool.
We know how to get rid of a fraction. Yep, that's the exact same thing. Multiplying by 3 and dividing by 2. That's just multiplying by 3 over 2, which is the reciprocal.
Okay, here we go. I'll watch.
He's going to watch. Okay, I need to get rid of this fraction in front of my x squared. So we multiply by 3 over 2. But I have to multiply every term.
Wait, so what? Oh, wait.
Times 3 over 2 times 3 over 2, and the y times 3 over 2. because now the 2's cancel and the 3's cancel, and that leaves us with just the x squared by itself, which is what we needed to do. But now I've got 3/2 y equals x squared. Okay, so 3/2 times 12. It's just 18, right? You can do 3 times 12 divided by 2, or what's easier, I always do 12 divided by 2 to get 6, and then multiply by 3 to get 18. So I actually do the division first, and then I multiply to give me a smaller number. So plus 18x, and over here, 2 on top, 2 on bottom, they would just cancel out and leave us with just the -3. Is this a perfect square trinomial? Not yet. So let's add 3 to both sides. Right, I got to cancel this out by adding 3. Adding 3 equals x squared plus 18x. And what's our magic number today, folks? Carlos says 81. Anybody agree with him?
Yes.
I do too. Plus 81 plus 81. Add that to the 3 on the left. Good. 3/2 y plus 84 equals, nice,
Squared.
awesome. Subtract the 84. 3/2 y equals x plus 9 squared minus 84. There's a fraction in front of the y. How do you cancel out a fraction?
Got it.
Multiply by the reciprocal. Flip it, just like we did in the very first step. Remember, we had 2/3 x squared.
So we just flip it again.
You flip it again. Multiply by 2/3. Now, that's easy right here, right? That 2/3 is just going to be in front of the parentheses, no calculation. But here, I've got to do a little bit of math. So to multiply that out, I would do the division first. What's 84 divided by 3? What's 81 divided by 3? It'll be, yeah, it is 28.
28 times 2.
Yes? What's,
Yeah, 56.
I
56.
am
I got it.
impressed. Minus
You
56.
said that one was going to be hard.
This isn't the last example.
Oh my god, I poured my whole, I poured like 3 pages of scratch.
Didn't I tell you that we're going to use like 8 sheets of paper today? I warned you, fair and square. There's a lot. For those of you listening, a student just pointed to the amazing circle graph on the sidewall in my classroom. That's called the unit circle, and that's going to be something fun we get to do in the spring. Oh boy. Oh, I'm sorry. Yeah, go ahead.
So go back to where, so the one up top where it says plus 81, like the screen right now, plus 81.
Yeah.
So plus 81, so 84, and then.
So then this, when I added 81, that made it a perfect square trinomial. So I could write it as x plus 9.
9 times 9 is 81.
Right?
And then you end up doing.
And then now I just keep this. I don't touch that. I leave that alone. I treat that like its own variable in a way. And I'm just now moving over the 84, and then I'm getting rid of the 3/2, right? Because I want to get the y by itself.
So minus 84 and then.
Subtracted 84 times 2 over 3. Yep, and that gives us that thing on the bottom. When you're writing, if we were graphing it, right? So if I were to ask you where the vertex is, this says x plus 9. The x coordinate of the vertex, right here. The vertex, Woji1, like Woji1 Kenobi, you know? -9, comma, -56. So the only time you flip the sign is right here for that x coordinate, because it says x plus 9 squared. My x coordinate of the vertex is a negative 9.
So I'm not gonna do it because I'm gonna learn it by then.
Good.
But if person does do that, do it now.
Moving on. Okay, I'm not going to have you do this one. What do I multiply in this problem? Multiply by 5, right? You don't need to do 5 over 1 necessarily. So this would be a nice, easy one. Just multiply by 5. Same thing. I think you've all practiced this enough that you don't need to do this one. So let's move on to the most difficult problem.
I got this. Ready, set, go.
I'm getting some angry eyes at me right now.
Got it. Did you get it right? All real numbers.
What? No. What?
Wait.
We're rewriting it in a different form. It's not a solve
Oh,
this equation.
okay.
Is that a perfect square trinomial?
No.
No. So what do we need to do?
You subtract the 4, please.
Sounds pretty easy to me. Y minus 4 equals x squared plus 3x. Piece of cake. Hey, everybody. What's the magic number?
It is 1.5 squared.
What's that?
Hmm.
1.25?
Okay, so my magic number is half of b squared, right? Do you remember that? That's like the first answer to the box earlier on. Take half of b and square it. So that's going to be 3 over 2 squared, right? Half of 3 squared. Instead of getting the decimal, 1.5, and then squaring it, keep it as a fraction. Because if I square a fraction, it's super easy. I just square the numerator
Easy.
and square the denominator.
I got it.
So it's just 9 over 4.
That's literally what I got.
That's literally amazing. Good job.
That's crazy.
So our magic number is 9 over 4.
Oh my god.
What is that in a fraction?
That's a fraction.
Wait.
That is a fraction.
Wait, what's the thing on the very right that you
This is how I calculated the magic number. How did I get 9 over 4? I started with 3. Okay, I started with 3. I divided by 2. Then I squared that. Just like on any other problem. Like over here.
Wait. Oh, that's solving for C. Okay.
Yep, getting the magic number, right? You take this number, divide it by 2, and square it.
Yeah.
So that's what I did here.
So then you
Divide this by 2 and square it, and we got 9 fourths.
put 6/4 as your what you call it?
No, 3 halves. Well, that is 6 fourths, you're right. Just, but you should
Yeah,
simplify it.
math can you do right now? I'm really trying, and my brain is just tired now.
You're so close.
I have to drive
What if
that.
this is on your test?
You would be plus
I'll get
16.
it going. Don't worry.
Hey, what about this right here? Can I add those up?
You would have to do plus 16 for it.
No, you cannot do.
So
That's what you would make it.
Common denominator.
You would make it 16 for it.
No.
I know.
Hey Siri.
Oh my gosh.
I'm
Yep,
not doing it.
yep. What do you mean? You don't get to choose. It's what I'm teaching you, and it's what I want you to learn.
Well, I had a good time today, guys.
Oh, you still have a whole nother 50 seconds
Very
remaining.
proud of all of our work today. Good job, River.
What? Look at this. We're giving up already.
Mr. Ojic, I have to drive. I
I
can't.
could have worked.
All right, everyone. This will be a fun one for you to do on the weekend by yourself. I want you all, I want you all to email me your answer to this.
Are you for real?
You got the whole thing finished?
I think it's a homework.
I want it in Vertex form.
I mean, I haven't paid attention.
You know, like the y equals blah, 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 x
No way
plus
I got that done that fast.
3 over 2 squared, blah, blah, blah. Like the whole Vertex form thing. But like you got to tell me, hey, what's A and then what's K? Just no. You all did amazing today. Please do the delta math to make sure you keep this locked in your brain. Okay?
Since I know it, I'll actually do it for you.
That's awesome. Thank you, everyone.
Have a good one.
Have the best day ever.